Hello and welcome to the third video in Module 7. In this video, we'll talk about how you can find a minimum sample size to create your confidence interval. So you can create a confidence interval with a particular margin of error and a certain level of confidence if you use a large enough sample size. So for example, suppose I wanted to be 98% confident in my confidence interval, but I only want a margin of error of 2. So how big of a sample would I need to ensure that criteria? That's what this video is about. The formula that we'll be using looks like this. So n is going to equal z times sigma over e, all of that squared. Now I found this formula by rearranging the formula for the margin of error, which involves the z-score and the sigma x-bar. And sigma x-bar involves sigma and n. So that's how we got a formula that involved n. You don't really have to know that, but the important part of this is notice that in this formula, it involves sigma. It does not involve sigma x-bar. So that's kind of the weirdness about this formula. This formula also represents a minimum sample size that you need. So if you get a decimal amount, you can't have anything less than that decimal. And since you can't really interview a part of a person, we'll always round up to the next whole amount. So for example, if my n turns out to be 13.1, I must interview 14 people, because 13 people would be just a little bit too little. It would not guarantee that I would have the margin of error I wanted with the level of confidence I wanted. So no matter what decimal you get, always round it up to the next whole amount. So let's do an example. In the last video, we found a 98% confidence interval for a sample of 6 different weights for a population that had a standard deviation of 1.02 grams. Suppose now we need to have a higher level of confidence. We need a 99.5% confidence interval with a margin of error of 0.5 gram. How big of a sample do we need to ensure this? It's probably going to be more than 6 weights. So I'm going to jot down our formula just so that we have it here. And when I look at the information that we have, I have my standard deviation of 1.02, so I know the sigma. And it says we want a margin of error of 0.5 grams, so I know the value for E is going to be 0.5. So the variable that I'm missing is the z-score. To find the z-score, I need to know the level of confidence that I'm going to be using. Since it says we're going to make a 99.5% confidence interval, that means we have to look up the z-score for the 99.5% confidence interval. When I did that, I got a z-score of 2.807. Does that match what you find? Once you have all of the values, it's just a matter of plugging into the formula and rounding our answer up at the end. So I'm going to substitute in the values 2.807 for the z-score, 1.02 for sigma, and the 0.5 for E. I'm going to carry out my operations in the order of operations. So I do 2.807 times 1.02. Then I'm going to divide that by half, and then I'm going to square my whole answer. When I did that, I wound up with a 32.79028. Rounding this up to the nearest whole amount will give me a sample of 33 weights. So if we wanted to make a 99.5% confidence interval with a margin of error of 0.5 grams, we'd have to have a sample of at least 33 weights. Now, remember back in the day when we talked about different sampling techniques, one of the things that could create a bias is a non-response bias. We didn't get enough people to respond. So if I was doing a confidence interval here, but it wasn't of weights, I needed to interview people, I would have to make sure if this, instead of just sending out 33 surveys, I'd probably want to send out a substantially more than that with the expectation that a lot of people won't return it. Now, this kind of example always shows up on the test for this unit, so you'll have an example like this on the test that you'll need to find, and it's one of the frequently missed questions. The reason I think it's a frequently missed question is because there's not a lot of depth to this example. It's just a formula and you plug and chug. So it's easy to forget about, and it's easy to not know what formula to use or what to find, since it's like not a big deal, right? So when you see a question that says, how big of a sample do you need? Or what sample size is required, that's your clue that you're going to need this formula. Also, another common mistake with this formula is forgetting to square at the end. So just doing that 2.807 times 1.02 divided by 0.5 and forgetting to do the squaring part at the end. So just make sure to carry out all of the operations. If you need it to break down in more than just the one step I have shown here, feel free to perform the operations in multiple steps as you work through. This concludes the video on finding minimum sample size. In the next video, we'll be creating confidence intervals again, but this time it will be for when we don't know the population standard deviation. Thanks for watching, and have a great day.